Hello. Today in this video we are going to see about free space propagation model in mobile radio propagation. Introduction. Propagation is a term used to describe the signal transmitted from the sending station to receiving stations. To ensure satisfactory performance of a wireless communication system, propagation models used as a suitable low-cost alternative for site measurements, and the propagation model is to predict the average received signal strength. Free space propagation model. The free space propagation model is used to predict received signal strength. The transmitter and receiver have a clear, unobstructed line of the site path between them. The free space model predicts that received power. The free space model, which decays as a function of the transmitter-receiver separation distance, rises to some power. Example: satellite communication system, microwave line of sight radio links. Free space equation. The free space power received by a receiver antenna, which is separated from a radiating transmitter antenna by a distance d. The free space equation shows that the received power falls off as the square of the transmitter receiver separation distance. This implies that the received power decays at a rate of 20 dB per decade with distance. Given by the free space equation, the received power PR of D equal to Pt Gt Gr lambda square divided by 4 pi the whole square d square L, where Pt is the transmitted power and Gt is the gain of the transmitter antenna, Gr is the gain of the receiver antenna, and D is the distance between transmitter and receiver, and L is the system loss factor. Lambda is the wavelength. Activity. Free space equation. Effective aperture is related to the gain of the antenna, where effective aperture AE is related by gain by means of G equal to 4 pi AE divided by lambda square, where lambda equal to 2 pi C omega C. In free equation, Gt and Gr is dimensionless quantity. The isotropic radiation is an ideal antenna which radiates power with unit gain uniformly in all directions. Path loss. Path loss is the measured in dB. Difference between the effective transmitted power and the received power may or may not be included the effect of the antenna gains. The path loss, which represents signal attenuation as a positive quantity measured in dB. It is defined as the difference between the effective transmitted power and the received power. The path loss for the free space model when antenna gain is given by path loss PL is equal to 10 log Pt by Pr. The path loss can be expanded to given an equation in terms of distance, and it is given by the equation as shown here, where c is the speed of the light. The free space model is only a valid prediction for received power in the far field of the transmitting antenna. Fraunhofer region. The far field or Fraunhofer region is a transmitting antenna is defined as the region beyond the largest linear dimension of transmitter antenna aperture and the carrier wavelength, where d is the largest physical linear dimension of the antenna. Close in distance. It does not hold for d equal to 0 and which is close in distance d0. Received power at reference point d0 is given by PR of d equal to Pt Gt Gr lambda square divided by 4 pi whole square d square L. The received power level is given as PR of d equal to PR of d0 into d0 by d the whole square, where d0 is less than d and greater than dt. Assessment questions. Free space equation is an expression for noise power, is a function of transmitting and receiving antenna gain, and it depends upon the distance between transmitting and receiver antenna. The answer is it is a function. All the three are correct. A free space model of propagation refers to According to free space equation, the receiver power falls with square of the distance between the transmitter and receiver, increases with square of the distance between the transmitter and receiver. Received power increases with gain of transmitting and receiving antenna. The answer 1 and 3 are correct. Thank you.